we now discuss the solution of a problem from the section Integral Calculus, and it is the second question on definite integrals in this paper. This question has appeared in the joint entrance examination main held on 26th June 2022 in the first shift. The given question is the value of the integral 48 by pi to the power of 4 integral 0 to pi in brackets 3 pi x square by 2 minus x cube multiplied by sin x by 1 plus cos square x with respect to x is equal to. So we required to find the value of this integral 48 by pi to the power of 4, the definite integral 0 to pi in brackets 3 pi x square by 2 minus x cube multiplied by sin x by 1 plus cos square x with respect to x. We now discuss the solution of the problem in detail. Let us denote the given integral by I. I is equal to 48 by pi to the power of 4 integral 0 to pi in brackets 3 pi x square by 2 minus x cube multiplied by sin x by 1 plus cos square x dx, that is equal to 48 by pi to the power of 4 as it is integral 0 to pi, and we have taken LCM here. So after taking the LCM you will get 3 pi x square minus x cube minus 2x cube whole by 2, and in the numerator x square is common, then x square by 2 is taken out, then you will get in brackets 3 pi minus 2x multiplied by sin x by 1 plus cos square x with respect to x. This 1 by 2 is taken outside, then it will be 48 by pi 48 by pi to the power of 4 into 1 by 2, that will be 24 by pi to the power of 4 integral 0 to pi x square into 3 pi minus 2x multiplied by sin x by 1 plus cos square x dx. Now this will imply I is equal to 24 by pi to the power of 4 I1. Let's call this as the equation 1, where I1 is this integral. So where I1 is equal to integral 0 to pi x square into 3 pi minus 2x multiplied by sin x by 1 plus cos square x dx, and call it as the equation 2. Agreed. Let this integrand be fx. Fx is equal to x square into 3 pi minus 2x into sin x by 1 plus cos square x. Then this I1 will be integral 0 to pi f of x dx. We use a property, and we have a property on the definite integrals, and I1 is equal to 0 to pi f of pi minus x dx. We have this property. Now wherever there is a x, you substitute pi minus x. That will be equal to 0 to pi x square, that is pi minus x whole square into 3 pi minus 2 into x, that is pi minus x, into sin x, sin of pi minus x by 1 plus cos of pi minus x whole square with respect to x. This will be equal to, that means this implies I1 is equal to integral 0 to pi minus x whole square into 3 pi minus 2 pi is pi, minus of minus x is plus, plus minus 2 into minus x is plus 2x. So pi minus x whole square into pi plus 2x into sin of pi minus x is sin x, cos of pi minus x is minus cos x, but there is a square, therefore 1 plus cos square x. So this is the equation 3. Now adding 2 and 3, you will get I1 plus I1 to I1 integral 0 to pi x square into 3 pi minus 2x plus pi minus x whole square into pi plus 2x. Pi plus 2x whole multiplied by sin x by 1 plus cos square x with respect to x. We continue in the next slide. Adding 2 and 3, we got this one. Now we will try to simplify. So I1 is equal to 2I1 is equal to this much. Therefore, I1 is equal to 1 by 2 integral 0 to pi, and we have multiplied x square multiplied by 3 pi x square minus x square multiplied by 2x, that is minus 2x cube. Pi minus x whole square is expanded. Pi square minus 2 pi x plus x square multiplied by pi plus 2x whole into sin x by 1 plus cos square x with respect to x. Now we multiply this, expand this, that is 1 by 2 integral 0 to pi 3 pi x square minus 2x cube as it is, pi square pi into pi square pi cube minus 2 pi x into pi minus 2 pi square x square into pi, that is pi x square, plus 2x into pi square, that is 2x pi square, plus into minus 4 pi x square plus 2x cube. Now 3 pi x square is 4 pi x square, there is a minus 4 pi x square, they cancel, minus 2x cube plus 2x cube, they cancel, 2 pi square x minus plus 2x pi square, they cancel each other, and we are left with only pi cube. That pi cube will come out of the integral. That is equal to pi cube by 2 integral 0 to pi, we use sin x by 1 plus cos square x dx. This integration is very easy. Now, so put cos x is equal to u. Cos x is equal to u. And then differentiating, you will get minus sin x dx is equal to du. Therefore, sin x dx will be minus du. Now, the limits will change now because of the substitution. Now, x is equal to 0 will imply u is equal to cos 0, that is 1. And when x is equal to pi, u will be cos pi, that is minus 1. So, when x is 0, u is 1. When x is pi, u is minus 1. Therefore, the integral now becomes integral minus 1 to plus 1 to minus 1. X is equal to 0 to pi, therefore 1 to minus 1. Therefore, substitution integral 1 to minus 1 sin x dx is minus du by 1 plus u square. Now, the integration is tan inverse u, that is tan inverse u, and 1 to minus 1, there is a minus sign, that we have reverted, and that will be minus 1 to plus 1. That minus is taken care of. And tan inverse of 1 is pi by 4 minus the lower limit. Tan inverse of minus 1. Tan inverse of minus 1 is minus pi by 4. So, pi by 4 plus pi by 4, that is equal to pi by 2. Tan inverse 1 upper limit is pi by 4 minus the lower limit tan inverse of minus 1. Tan inverse of minus 1 is minus pi by 4. So, pi by 4 plus pi by 4 is pi by 2. So, the integral 0 to pi sin x by 1 plus cos square x with respect to x is pi by 2. Let's go back. Come back here. That is equal to pi cube by 2 into this integral we have seen here, it is pi by 2. So, multiplying, we will get pi to the power of 4 by 4. Let's go back to find the value of I here. So, from 1, I is equal to 24 by pi to the power of 4 into I1, but I1 value we have pi by 4, pi to the power of 4 by 4. So, multiply 24 by pi to the power of 4 multiplied by I1 pi to the power of 4 by 4, pi to the power of 4, pi to the power of 4 cancels, 24 by 4, the 4 ones are 4, 4 6s are 24, so that is equal to 6. That's our answer to that given integral. That is the detailed discussion of the solution of the problem on definite integrals from the integral calculus. This is a routine example using that property, always what people sometimes call that property as the King's property, and that basing on that property, many a times questions are coming of this type. And I'm sure that you have understood the solution of this problem, and I wish you all the best. Thank you.